You might recall that if the hypotenuse and one side of a right-angled triangle is equal to the hypotenuse and one side of another triangle respectively, then both the triangles are congruent. This rule of congruency is also known as the RHS congruency criterion. So far, we have learned the construction of triangles based on SSS criterion, SAS criterion, and ASA criterion. Now, we will construct a triangle based on the RHS criterion. Suppose we have to construct a right-angled triangle ABC. In ABC, the measure of angle B is 90 degree, the length of the hypotenuse AC is 5.7 cm and the length of the side BC is 4.5 cm. Let us construct a triangle ABC with the given measurements. Step 1. First of all, we will draw a rough figure of triangle ABC with the given measurements and mark the given measurements on it. Drawing a rough figure gives us an idea of how a triangle can be formed. Step 2. Here, the length of the side BC is 4.5 cm. Therefore, we will draw a line segment of length 4.5 cm with the help of a ruler. We will name this line segment BC. This line segment is the side BC of triangle ABC. Step 3. Since angle B measures 90 degree, we will draw a ray BX which is perpendicular to the line segment BC at point B. We can construct this by marking a point at 90 degree using the protractor and draw a ray BX passing through it. Where should the point A be situated on the ray BX? Can you tell how to find the position of the point A? Think for a while. You got it right. We know that hypotenuse AC is equal to 5.7 cm. Let's get the position of the point A with the help of this. Step 4. The length of the hypotenuse AC is 5.7 cm. This means that the vertex A is at a distance of 5.7 cm from the vertex C. So, to determine the position of the vertex A on ray BX, we will measure a radius of 5.7 cm on the compass and draw an arc on the ray BX with point C as the center. Step 5. The arc intersects the ray BX at a point. The point of intersection is the point A. Therefore, now we will join the vertex A and the vertex C, from which we will get side AC of triangle ABC. In this way, we have completed the construction of triangle ABC in which the measure of angle B is 90 degree, the length of the hypotenuse AC is 5.7 cm and the length of the side BC is 4.5 cm. Similarly, if we construct a triangle RPQ in which angle P is equal to angle B is equal to 90 degree, hypotenuse RQ is equal to AC is equal to 5.7 cm and the side PQ is equal to BC is equal to 4.5 cm, then the obtained triangle RPQ will be congruent to triangle ABC. That is, if we place triangle RPQ on triangle ABC, then we will be able to see that triangle RPQ covers the triangle ABC completely. That is, both the triangles are of the same size and shape, which means triangle RPQ and triangle ABC are congruent. Thus, we can say that by using the RHS criterion, we get a unique triangle. So today we learned the construction of a right-angled triangle when the length of one of its legs and the length of its hypotenuse is given. In the next video, we will of a right-angled triangle when the length of its one leg and the hypotenuse is known. Let's look at an example for this. Raj walked 10 steps in the northeast direction, then moved 6 steps towards south and then returned to the starting point. While walking, all of Raj's steps were equal in length. Find out which figure can be constructed for the given situation. First of all, we will make a rough figure and find out which figure we will get. For this, we need to know about the directions So, let's understand them first. You must recall that there are 4 major directions: east, west, north, and south. With this, the directions in between them are the northeast, northwest, southwest, and southeast, which we depict as given in this figure. So now, let's solve our questions with the understanding of the directions. We will mark the location of Raj with the point P. Raj walked 10 steps towards the northeast direction. Suppose 1 step is equal to 1 centimeter. We will show this by drawing the line segment PQ in the northeast direction. Then, Raj walked 6 steps towards the south. We will show this by drawing the line segment QR towards the south. And then, Raj returned to the starting point. We will show this by joining the points P and R to obtain the line segment PR. We see that we have obtained a triangle. Therefore, we can say that a triangle will be formed in the given situation. On the basis of the angles, can you tell the type of a triangle that is formed? Think for a while. Let me tell you. We see that point P is in the west direction from point R and point Q is in the north direction. This means that the side PR and the side QR form a right angle with each other. That is, triangle PQR is a right angle triangle. Since triangle PQR is a right angle triangle in which angle R is a right angle, we can say that in triangle PQR, the side PQ is the hypotenuse and the sides QR and PR are the legs. If we use the given measurements, we can say that hypotenuse PQ is equal to 10 steps is equal to 10 centimeter and the side QR is equal to 6 steps is equal to 6 centimeter. Since we know the measurement of the hypotenuse and a side of a right-angled triangle, we can construct a unique triangle using the RHS criterion. So, let us construct a right-angled triangle, triangle PQR. Step 1. We have drawn a rough figure of triangle PQR already. Keeping this in view, we will construct triangle PQR. Step 2. Now, with the help of a ruler, we will draw the side QR of length 6 cm of the same measurement as triangle PQR. In this video, we are drawing the side QR in the vertical direction. But it is not necessary to do so. You can also draw it in the horizontal direction. Step 3. Now, we will draw a perpendicular RS on the side QR which passes through the point R. Vertex P must be located somewhere on this perpendicular. Step 4. To find the location of the vertex P, we will take a measure of 10 cm on the compass and draw an arc by placing the sharp edge of the compass on the point Q, cutting the ray RS. The point of intersection is the vertex P of triangle PQR. Step 5. Then, by joining the vertex P to the point Q, draw the hypotenuse PQ of triangle PQR. This will complete the construction of triangle PQR. Today we saw another interesting example related to the construction of a right-angle triangle when the length of its one leg and the hypotenuse is known.
Rahul has to construct a triangle ABC. In triangle ABC, we are given that the length of the side AB is 2.7 cm, the length of side BC is 4.7 cm and the angle B measures 65 degree. Rahul knows how to construct a triangle based on the SSS criterion. Under the SSS criterion, the length of all three sides of a triangle must be known in order to construct a triangle. Here, Rahul knows the length of sides AB and BC of triangle ABC, but he doesn't know the length of side CA. As a result, Rahul failed to construct a triangle ABC. So tell me, could Rahul construct a triangle ABC using the information provided? Let's see. In the chapter Congruence of Triangles, we learned that two sides and the angle included between them of a triangle are equal to two corresponding sides and the angle included between them of another triangle, then the triangles are congruent. This rule of congruence of triangles is called the SAS congruence criterion. This rule also informs us that if two sides and the angle included between them are given, then we can construct a unique triangle. Let's construct triangle ABC based on SAS criterion. Step 1. First, we draw a rough diagram with the given measures. This helps us to determine the procedure in construction. In this way, we will be able to construct the triangle easily. Step 2. Next, draw a line segment BC of length 4.7 cm. Step 3. Here we have sides BC and AB and the angle B measuring 65 degree included between them. With B as the center, draw an angle of 65 degree with the help of a protractor. Draw a ray at point B. We will label the ray BD. The ray BD makes an angle of 65 degree with the line segment BC. The point A must be somewhere on this ray of the angle and we have to determine the exact location of point A on ray BD. Step 4. The length of AB has been given as 2.7 cm. Thus, point B is at a distance of 2.7 cm from point A. With B as the center, draw an arc on ray BD of radius 2.7 cm. The arc cuts ray BD at a point. This point of intersection is the vertex A of triangle ABC. Step 5. Join points C and A to get the third side of the triangle ABC, that is CA. Thus, we obtained triangle ABC using the SAS congruence criterion. Today we learned how to construct a triangle when the lengths of two sides and the measure of the angle between them are known. In the next video, we will see in triangle BCE, we have BC is equal to 3.8 cm, CE is equal to 6.2 cm and angle BCE is equal to 55 degrees. Construct triangle BCE. Here, we have to construct triangle BCE. We are given the length of two sides of triangle BCE and one angle. CE is equal to 6.2 cm. Angle BCE is equal to 55 degree. BC is equal to 3.8 cm. Since we know the length of two sides of the triangle and the measure of the angle included between them, angle C, we can construct triangle BCE using the SAS criterion. Step 1. First, we draw a rough diagram with the given measures. This helps us to determine the procedure in construction. Step 2. Next, draw a line segment CE of length 6.2 cm. Step 3. Using a protractor, construct an angle of 55 degree at point C. In other words, we will draw a ray CA at point C which makes an angle of 55 degree with the line segment CE. The point B must be somewhere on this ray of the angle CA. Step 4. The length of BC has been given as 3.8 cm. Therefore, point B is at a distance of 3.8 cm from point C. We will open the compass with the required radius of 3.8 cm. With C as center, draw an arc of radius 3.8 cm. It cuts the line segment CA at a point B. This point of intersection is also the vertex B of the triangle. Step 5. Now we will join vertex B and vertex E and form EB. Thus, we obtained triangle BCE, where BC is equal to 3.8 cm, CE is equal to 6.2 cm, and angle BCE is equal to 55 degree. In the next example, in triangle ZYX, we have ZY is equal to 4.7 cm, YX is equal to 4.7 cm, and angle Y is equal to 35 degree. Based on the data provided, find out what type of triangle is triangle ZYX. Construct triangle ZYX. Here, we have to find the type of triangle ZYX and construct triangle ZYX. In triangle ZYX, ZY is equal to 4.7 cm, YX is equal to 4.7 cm, and angle Y is equal to 35 degrees. Here, we know that ZY is equal to YX, but we do not know the length of the third side. We can say that triangle ZYX can be an isosceles triangle or an equilateral triangle. Can you tell us how can we find out which of the two types of triangle is triangle ZYX? Think for a while. Absolutely right. Here, angle Y is equal to 35 degree. You will remember that all the angles of an equilateral triangle are 60 degree. Since the measure of angle Y is not 60 degree, we can say that triangle ZYX cannot be an equilateral triangle, which means it is definitely an isosceles triangle. Thus, by properly understanding the information provided, you can answer any question correctly. Now let's construct triangle ZYX. Step 1. First, with the help of a ruler, draw a line segment YX of length 4.7 cm. Step 2. With the help of a protractor, draw an angle of 35 degree at point Y with line YX. In other words, we will draw a ray YV at point Y which makes an angle of 35 degree with the line YX. The point Z must be somewhere on this ray of the angle YV. Step 3. The distance of ZY has been given as 4.7 cm. Thus, point Y is at a distance of 4.7 cm from point Z. With Y as center, draw an arc of radius 4.7 cm. It cuts ray YV at point Z. Step 4. Next, we will join points Z and X and draw the third side ZX, which completes the construction of the triangle. Thus, we have obtained triangle ZYX, where ZY is equal to 4.7 cm, YX is equal to 4.7 cm, and angle Y is equal to 35 degrees. Today we saw some examples related to construction of a triangle when the lengths of two sides and the measure of the angle between them are given. When the lengths of two sides and the measure of the angle between them are given. The length of one side other than the hypotenuse of a right-angled isosceles triangle is 5.2 cm. Construct a right-angled isosceles triangle. Here, we are given the length of just one side to construct a triangle. Is that enough? Think for a while. Let me explain. Here, we are given the length of one side, but we are also provided with some important information. Like we have to construct a right-angled isosceles triangle. From right angle, we infer that the triangle has a right angle, that is, an angle of 90 degree. And from isosceles, we infer that in this triangle, two sides other than the hypotenuse are equal. In short, we have to construct a triangle LMN where MN is equal to ML is equal to 5.2 centimeter and angle M is equal to 90 degree. Here we can construct triangle LMN using the SAS criterion. Now let's construct triangle LMN. Step 1. First, with the help of a ruler, draw a line segment MN of length 5.2 centimeter. Step 2. As we know, angle M measures 90 degree. We will draw the ray MO. The ray MO forms an angle of 90 degree with the line segment MN. Step 3. We know the length of the other side which measures 5.2 centimeter. Therefore, we will open the compass for the required radius of 5.2 centimeter. With M as a center and a radius of 5.2 centimeter, we will draw an arc. It intersects the ray MO at a point L. ML is the second side of triangle LMN. Step 4. Now, we have two sides of the triangle. Next, we will join point L and N and form the third side of the triangle LMN, which is the hypotenuse LN. Thus, we have obtained a right-angled isosceles triangle LMN where MN is equal to ML is equal to 5.2 centimeter and angle M is equal to 90 degree. So today we saw some examples related to the construction of a triangle when the lengths of two sides and the measure of the angle between them are given.